Nope. Clancy even on? Oh, Clancy was just the one that brought that up.
Wow.
What's up?
What's everyone else doing?
Yeah, what is everybody else doing? Nobody else. So these other people probably really aren't on.
Oh, they're taking a nap.
Yeah. You can always tell too at the end of class. You got like 2 or 3 people, they're just, and they're not sitting at their computers. They haven't been there for a while. Oh, and it's so true too.
This is gonna go for an hour to see how many people are still.
That's what I got to do. I have to, so then when we do these little in-class exercises, I should have you message me your answer on Slack. Even if it's not like complete, like ran out of time, if I pick up, but at least like you were working on it. And then just give them zeros on the final exam if they didn't do it. Destructive. All right. So we have a repeat statement now that does something for so long. Do we have Booleans yet? I think we do because we have if conditionals, right? Let's see. Yeah, we have a test statement now. So we have something right now that will repeat something some number of times. So maybe our next idea would be to have something like a while loop that does something while a certain condition is true, right? Okay, so because that might be something if we want to count down, because now we're starting to get, we're starting to get to the point where we can almost start solving real problems in our language, right? Like actually doing stuff. All right, so maybe we have maybe a while. So we're thinking about this like a while loop. Maybe we'll change the name of it in a second. So we want to do while something is true. All right, so maybe we do while something like well, I'll just call it a bool expression right now. And then we'll have the body, what we should do while that's true. Something along those lines, with the idea that this guy should have an impact on whatever this is testing. If we only need to repeat something some number of times, we might just use a repeat. All right. If we need to repeat something until some condition is true, we would do something like this. So if we give ourselves like an example of this using some of our test stuff up here, we might say like while well, actually, let's write it down here. Let's give ourselves a expression. So we'll start off with a parse program on it. Parse expression. So this is going to be a while, and then we'll steal that I got the test expression. So before this, I might do in order. And I might say, remember, A is 1, literal 1, right? Like that. And then I'll say, while A is less than 7, do we have the ability to update a value? Or we just have ability to create a new one. Probably want to have a way of updating a value in the current environment. We have a way of remembering a new value, but we want to have a way of updating an existing value. All right, so let's write that first. So that might look something like update A 15, or literal 15, something like that, some expression. And that presumes that it's already in our environment, and we want to go and find it and change its value in our environment. Okay, which is actually going to be a relatively difficult thing to do because of the way our environment is set up as an extend env, right? Okay, so our environment is this extend env environment, which has a lot of structure to it, which is nice enough. But what I need to do now is I need to go through and find the part of my environment that a variable is in, and then update that. So we can go up to the top here and work with our environment things. I'm interested now who didn't show up. Oh man, look at that. We're missing a whole bunch of people. Oh, and just a reminder, the department hackathon is this Saturday from 9 a.m. to 8 p.m. or something like that, 7 p.m. I think you need to be signed up by Friday, but I would say sign up as soon as you can. Details are on Slack already with the link to sign up. They are looking for another team lead or two, so that should probably come from classes like this, your senior level classes. So if some of you haven't signed up, or who know somebody else who is upper division who might be a good team lead, maybe reach out to them and suggest they join the hackathon. These are always good experiences. You learn a bunch of stuff. So in any case, there's your public service announcement for that. All right, so we want to create the ability to update something in our environment. Before we add it to the language, let's go ahead and let's write the ability for this into our variable environment. We haven't revisited the variable environment in a while. All right, so one of the things we need to start thinking about, and let's kind of look at this in terms of an extend env, and we'll go back to the slides for this. Scopes for our environment. All right, so our environment currently is a collection. Let's just kind of play it out with the whole scoping issue. So we're going to say that we have this thing called extend env. And then we'll say A5 onto an extend env B7. Keep it onto an empty env. Something like that. So that's kind of how our current environment works. All right. And we have a couple of like helper things that allow us to add a whole bunch of variables at once. But it ultimately builds a structure that looks like this. All right. Now, if that's our current environment, and then we start going down, we've had good practice already working with like sub scopes. So for instance, when we do a let or a let star or a let rec, we are creating a more local environment that lives and dies in this period of time and then goes away, right? So in that, especially since now we have a remember, nothing keeps us from saying, well, we're going to remember A is 13, which then is going to give us an updated environment that looks like that. Okay, now this works for us right now because the way we're resolving variables is we walk through our environment from beginning to the end, and we will find our more local A first, right? But what happens, presumably, if we're thinking forward a little bit, we're probably going to be writing functions pretty soon, right? And then writing classes. So this idea of having localized and variable environments are not far from us right now. Okay, so let's assume that we are in one of those localized environments right now where we just added A equals 13 as a quote local variable. All right. Well, now we have the problem of saying that local environment has now ended. The function ended. The do in order ended. A loop ended. Whatever we decide we're going to associate local environments with. That's now over, and we want to revert back to this afterwards. Now, in this case, we see that we only added one thing. What if we added more than one thing? How do we revert our environment back to where it was before, or how do we enhance our variable environment to support scopes? What effectively is a scope-based environment? When I say scope, I'm talking about a saying we might use is that all variables resolve to their most local definition, where the most local definition is in the, well, let's say, where the first place to search is the most local scope. And then we check scopes higher in the hierarchy as we do not find what we are looking for. That makes sense? So starting point here is this a reasonable way of storing name value pairs in a individual scope? We haven't defined a structure for scopes yet, but in our idea, if we are inside of a function and we want to look up local variables for that function, is this a reasonable enough representation of name value pairs for a local environment? Yeah, it's worked for us up to this point, right? We're only starting to stretch it a bit now because we're thinking, oh, well, I might have environments that I want to create temporarily and then disappear very shortly, right? So we want to think about how does this work in a language like in our modern languages when we have, let's just see what my Eclipse looks like right now. Yeah, so I have a couple of, so if I say string s, well, actually, we already have some variables in here. Okay, so here's my main. I have 3 variables in here, WB1, WB2, WB3. We're looking at multi-threading stuff. So we have 3 variables in here, and these are local to the scope of main, right? But now, as soon as I created WB1, WB2, WB3, a brand new scope was created inside of this class. So now we have a scope associated with WB1. That is the scope that governs this, where we have a variable called name. Then we have even a further subscope inside of run where we have a variable named I, right? Where we're able to still access. So if I'm inside run here and I say, oh, give me the value for name, it's not going to find a local version of name here. I'm giving it a little help here and telling it to, oh, just go up to this dot. If I leave that off, it still runs. So now when I say, hey, find me the most recent, the most local definition of a variable named name, it'll first look in the scope that was created for run, and it'll say, I didn't find it there. Then it'll bounce up to its the next closest scope in its same hierarchy, right? It can't, if I have a variable in here, int b is equal to 4, this guy doesn't have access to b because this scope and this scope are not in the same hierarchy. They both belong within the hierarchy of this guy, but they are in, when I finish looking here, the next place to look is here. I don't get to look inside of this scope because it's not available to me. Make sense? All right, so we can see here that we have several scopes that are getting created, and as soon as this run method is done, this scope that was associated with this, where I have this variable name I, it's gone. Nobody else has access to it. I don't want to store it anymore. I don't want somebody else to accidentally look up the value of I and find an old leftover variable that had been accumulated for a while, right? Okay, so I need to get rid of those. So we need to think about how do we implement a variable environment that is compatible with scopes. All right, now when we really think about a scope, I'm going to, let's just do it within worker B here for our example. Okay, so I have my top level scope. All right, so I have the scope governed by worker B in my example for whatever. All right, and inside this scope, I have a variable named name. That's available to me in that scope. All right, then within that, I have my worker B. I'll just label it as the constructor. We'll color code this dude. All right, and he has, well here, as I wrote this, he has an int B equals 5, whatever. All right, so he has a name. He also has a variable called B. All right, then we get down to our run method. And inside there, we have a variable named I. Like this. Okay. So this is our hierarchy of our environments. And you can even look at it, I guess, if you want to think about it like this. Because these two are at the same level. Their direct parent is the worker B class. So this is, we can call this the worker B class. Okay. So if we were to translate this into our current organization, we have a extend env name, I'll just put a placeholder in there for now, Mike, onto empty env. All right, that's the environment that was created right there. But now when run gets called, a new environment is created. That is the environment, Ninja. That is the environment that has I is equal to, starts off at 0, let's say. That is that environment. But now this environment needs to know that its parent is this one. So I have this environment is the one I'm going to check first. If I don't find what I'm looking for in here, I'm going to bounce up to my next environment. How can we store these two environments separately, but in a way that we can make sure we get to the correct next environment each time? Could have a list of environments, okay? And so what would be the most local environment we would look at? First thing in the list, okay? What would be the next one? Second thing, and then the third thing, and then the fourth thing. So would it be fair to say that instead of a list, could we use a stack? Where if we have the current environment, we would push a new environment onto the top of the stack. The top of the stack is where we're going to try to look for first. And then if we don't find it there, we will pop off the stack and check the new top of the stack. And as soon as we run out of stuff on the stack, that means that we are out of places to look and we have an error or something like that. All right, so really what we want to do is we want to create a stack of these guys. So here, let's do that in, create a stack of these guys. Always have to use my great ninja skills here. So this will be my most local environment. This will be the next most local environment. So initially I have this guy. And then once I call run, I push my new environment onto the top of this stack. When run ends, I can pop this environment off the stack, leaving my stack back where it needs to be for this. That makes sense? So when I went into my worker bee constructor, which gave me this thing, b is equal to whatever I had, equal to 5 maybe. Okay. When I'm in that constructor, I have access to this variable name, but now I also have access to a more local variable b. And as soon as my constructor was done, I can pop this off and I don't need it anymore. And then when I call run, this gets pushed on to my stack of environments. Make sense? So that kind of a reasonable way of maybe holding scopes is to have a stack of environments. Whenever we enter into a new scope, we could push the environment associated with that new scope onto the top of our stack of environments, because all variables always resolve to their most local definition. And then when I'm going and looking up an environment, I can update. Well, when I'm looking up a value, if I don't find it in the first one, I can pop from the top of the stack and find it in the second one. I need to make sure, though, that after I'm done doing that, I haven't broken my environment forever. But I'm actually okay, because doing the only way we could store something permanently is through a set bang. So when we make changes to a list, we make changes to a stack of environments, those are only temporary. We're not actually overwriting the original variable. I'm just searching through a stack of environments for a variable. Make sense?
So in scheme, we're always like passing the environment around.
Yep.
Are we passing the most local one around, or are we gonna be passing the stack around?
Well, we'll be passing the stack around that has the most local one being the top. Yeah, because we need access to all of it. But yeah, that's a good point. So initially we'll have a stack of one environment. Now, we can decide that this is a stack of environments, or we can decide that that's the environment, and the way an environment is implemented is as a stack of scopes, right? So we can really call this guy now a scope, where the environment is a stack of one of those guys. So we can kind of decide how we want to write it, but that seems to be a reasonable enough way of thinking about it. Okay, so if we come back in here, we're just going to go all the way up to our empty environment. Okay, so really empty environment, we could rename this guy as the empty scope, correct? So we can say empty scope here, where it's going to create a list of an empty scope. And then we can have extend scope with a name value pair, creating an extend scope. Just changing naming a little bit here to kind of get us where you were asking, where I think we still want to call it the environment we're passing around. Just the nature of the environment is now a stack of scopes. Okay, so extend scope will be same thing we had before, just with a little verbiage updated. Okay, extend scope star, which is just a little helper function thing we have here. We'll have the same thing as we had before. All right, so then we have the get name from a environment. So I'm going to go ahead and update these to say be scopes too, since that's what we're operating on. So this is going to take in a scope. This will take in a scope. Get the environment, get the scope, we'll take in a scope and return the scope portion of that. Empty scope will return true if the car of it is empty scope. All right, so now we're going to update apply env to be apply scope. This is how do we look for a variable within a specific scope. So at this point, we're not changing logic, we're just changing variable names just to keep us, and then we're going to have a apply env, which will operate on a stack of scopes. Okay, so we're going to update this guy to be apply scope. It'll take in a variable name and a scope, and it'll search through here. All right, like that. Did I get all of them? Scope. And we know we didn't find something inside of our scope by we get a false from there, right? Okay. And then for has binding, we'll take in a scope, and then we'll call apply scope on the variable name and that scope. So that's just our quick thing to find out, is there a binding inside of a scope that might be helpful for us. Okay, so now we have this idea of apply scope. Now, several of our things in our language right now just broke, right? But not too much, okay? Because of the way we've written this, we are now promising that we're going to add in apply env. So we have this idea of apply scope now. We want to add in a apply env that works on a stack of scopes. So we want to define apply env. That will take it, be a lambda that takes in a var name we're looking for, and it takes in a stack of scopes. Okay, and this guy should boil down to the most local definition of var name in our stack of scopes. Make sense? Okay, so take a couple minutes, try to write this. Send me a private message on Slack with your code when either you're done or I start writing the next thing. I'm not going to grade it for correctness. I'm grading it for were you participating in, well, I probably won't grade it, but I will remember whether or not you were participating in class or not. Oh, no? Nope, that's not it. All right, should have the most local copy now. So take a couple minutes and give that a shot. We're writing apply env, which I already have started for you in here, which should boil down to the value associated with the variable from the most local scope in our stack of scopes, or false if it just never found it. just got to class. I was stuck at work. What is going on? Huh? It was Noah. All right. So let's look at this now. What is going on? Oh, I just stopped sharing, didn't I? All right. So Noah, we're we're writing our apply env here in the context of a stack of scopes. So what we've done is we have renamed our old variable environments to be now called scopes. They work identically to how they worked before. They're just now scopes instead of environments. And now we're calling it environment, where environments operate on a stack of scopes. All right, where we always look at the most local scope first and then start peeling away until we get to our final answer.
That makes sense.
All right. So let's see. So for apply env, we're taking in a stack of scopes. We are interested in the hopefully finding our var in the most local scope. Now we do have the ability to ask if something has a binding, right? We can give it a variable name and a scope. So we can ask if this variable has a binding. So I'll go ahead and write it as a cond. And we'll say has binding var name on the car of our stack of scopes. Now, what I probably would do here is I'm going to write a push pop peak just to give myself some like known things to really reinforce that we're working with a stack. So ahead of this, I'll just do a define. I'm going to give myself a peak first. Let's just look at the top of the stack. So let's call this guy peak env. I think that's probably a decent name for it. And this will be a lambda that takes in a stack of scopes. And he's going to, maybe we'll ask the question, if null stack of scopes, just boil down to false. I don't have anything, I have nothing to give you, something like that. Otherwise, we'll boil down to the car of stack of scopes, like that. So that is peak env. All right. Now, pop env. In fact, why don't we just, we're using peak right now. Let's go use it, then we'll build the other ones as we need them, because we'll have to decide how do we want pop to actually work. What's in my mind right now is I'm thinking maybe pop returns a list containing the first scope as the first element and the remaining stack as the next element. That's a possible way we could handle it, but we only need peak for this exact second. So let's just do that. So where are we checking to see if there's a binding? We're checking in the peak env of our stack of scopes. Okay. So if there is a binding in our peak env stack of scopes, then we want to go ahead and say apply scope on our variable name and our peak stack of scopes. We found a binding in our most local thing, so we'll go ahead and call apply scope on that particular scope. That's if it has a binding. If it doesn't have a binding, now, actually, I probably am missing one thing here. We probably want to ask if we're looking at a null stack of scopes. So we'll put that at the top of our cond. So null stack of scopes. We'll have this guy return false. Similar behavior to what apply env did before. Like, I didn't find it. I looked everywhere and I didn't find it. Not there. Okay. So if we've run out of places to check, we'll return false. Otherwise, if there is a binding in the top of our stack, we'll return the apply scope of that variable in the top of the stack. Else, we want to call apply env on the var name, and then we want to give it the rest of that stack of scopes, the next thing to look at. So now we could easily, so let's just write down what we can easily say. We're going to say the cooter of our stack of scopes, and that's correct, right? We can write it like that, and that's correct. But if we want to keep things written in terms of getters and mutators, or getters and setters, as well as some of our accessor methods. What do we call them in here? Forgot what the book's called. Extractors, thank you. So if we want to write this in terms of our extractors, what we probably want to do is we want to give myself a maybe a function called we call pop because I really want the environment resulting in popping of the top scope. We could do that, called remove scope. It's not a bad idea. At least it has some meaning to it. So define remove scope to be a lambda that's going to take in a stack of scopes, and it's just going to return the cooter of that stack of scopes. Okay. Now, I realize that that's, not like an overly impressive little function, but it is something that I think when we add it into here, rather than just having this arbitrary cooter, if we say remove scope from our stack of scopes, that implies that we're removing the top scope, looking at the rest of the scope, rest of the scope, something like that. All right, so that should get us back to apply env now. So now we should have a working apply env again, with the difference now being that my starter environment. So we need to have a constructor for the empty env. So let's put that down here. So we'll say define empty env to be a lambda that takes in nothing and boils down to nothing. The empty stack. That's what that guy is. He's the empty stack. All right. So now so that will be our empty environment containing no scope. So now what we want to do is we probably want to do this. We probably want to be a stack that contains a single scope that is the empty env. I think that is probably a better starting point. So the empty environment is a stack containing one scope that has nothing in it. We can decide that that's what our 0 is. So if you're kind of connecting this back to some of the functions that we had in the book that didn't feel like language stuff, when we were dealing with successors and predecessors and we had to have a baseline of a 0, right here we're choosing what is the baseline for an empty environment. Well, we can say it's just the empty stack. There isn't a scope, period, no scope. Or we could say, well, you know what? The simplest environment that can exist is an environment containing the most global scope, one scope, that has no variables defined in it. Is that reasonable? Go ahead.
So in terms of like what's within what, Env is the highest, then stack, then scope.
Did I just fix it?
I don't know.
Yeah, you're right. So I wrote the wrong thing in here.
Okay.
Sorry. So my empty env will be a stack of scopes. So env is the big guy. He's like a bag, and scopes fit inside of that guy. So we're going to say that the starter environment, if I program just started, and I haven't defined any variables, I have a environment that has exactly one scope in it, my global scope, and it currently has no variables defined. That's what I'm trying to depict here. That is, here's my environment, and in that environment is a single scope, which is the empty scope.
What if you want to say empty stack?
Well, I don't have an empty stack. So my environment is actually a list. It's a list that we're using, we're working with as if it's a stack. By doing pops and stuff like that, we're going to have a push soon. So the simplest environment, if we don't think about how we're manipulating it, when we first start a Java program, let's say, and we don't have any variables defined yet, there still exists that global variable environment that has nothing in it. So what we're saying is our starting point for our environment here is we have, so let's see, where's it at? That guy. So this is my empty environment. There's nothing on that stack. But now what I'll do is I'll go ahead and add my global scope, which currently has nothing in it. So I pushed onto the stack a single scope that is empty, that I can then extend with variables as I add things within that scope. Make sense? Okay, so that is our empty env. Now we want to have the ability to, we already have the ability to extend a, scope, but we probably also want to have the ability to add a new scope to our environment. And adding a new scope would be the idea of taking whatever the current environment is and pushing an empty scope onto it that can then be expanded. So if we want to say, where's my pushes and stuff? Yeah, I think this will be okay. So I'm going to go ahead and I'm going to define push scope will be a lambda that's going to take in a stack of scopes. Well, really, he's going to take in an environment, right? Which is a stack of scopes. So we can decide how we want to, are we cool with calling it an environment and knowing that it's a stack of scopes? Or do we like better to think about our environment as a stack of scopes and remind ourselves that the variable we're taking in, instead of being called env, is called a stack of scopes?
I say stack.
Okay, so stack of scopes would be the, it's not inaccurate, but it would be the least abstract. If we're talking about abstract data types, calling an env, knowing that the way it's actually implemented is as a stack of scopes, would be the preferred way of doing it. So somewhere we should remember that a env is a stack of scopes. That's the way we've implemented our environment. But really, when we talk about pushing a scope, we're pushing it onto an environment. What are we pushing? We're pushing a scope onto that environment. And then what will this ultimately do? This will cons that scope onto the current environment, because the current environment is a stack of scopes and we are consing a new scope onto the front of that. So that's what pushing a scope would do. And with that in mind, if we're updating these other ones, we would call this guy peak scope. And we're peaking a scope from an environment. That makes sense? So we have push scope, we have peak scope, because those are the things we're doing to interact with our environment. Just like we have remove scope. And this guy will produce for us. We're removing a scope from an environment and he will produce for us the rest of that environment. So then apply env is going to take in an environment. If we're out of things in our environment, return false. This is now called a peak scope, env, peak scope, env, env. All right, so now we have the ability to create an empty env. And really what we can do is we can say we want the empty env to be a lambda that takes in nothing. And what it does is it calls, you know what? I can make it look fancier, but really that's what it's going to result to. So we might as well just hard code it in there. A list containing the empty scope. We're using constructor for the empty scope here, and we're just saying that an empty env will produce a stack of scopes where it's just one scope. All right, so now we need to define extend env. Where extend env will take in a lambda and it'll take in a var name and a var value in the environment that we're extending. And the presumption is that we are going to be extending the scope that is the top thing in the environment. So how do we get the top scope? We get this top scope by saying peak scope. So I'm just going to go ahead and give myself a let here. So we're going to call this guy the top scope will be peak scope on env. Okay, so that's going to be my top scope. And then what do I want to do to my top scope? I want to extend that scope. And this guy here, instead of extend scope, should take in a scope as a parameter. Same thing, this guy should take in a scope just making sure any place we used to call an environment is now called a scope because our environment now has a new definition where it's a stack of scopes. So I want to call extend scope var name, var value, given the top scope. That's the scope I'm extending. Now we can actually do this inside of our let star, let's say. So I'm going to say new, actually let's call it extended scope, will be the result of calling extend scope on our top scope that we just got. All right. Then we're going to call temp env to be the remove scope of our env, which gives us everything but the first element. And then I'm ultimately going to, did I have a push scope, add scope, push scope? And I'll move push scope to be just right before this extend env. So what I'm ultimately going to boil down to is a push scope. What scope? The top scope onto my temp environment. So my extend env is going to go ahead and grab the top of my stack. Then it's going to extend that scope with my new name value pair. And then I'll also get the rest of my environment except for that top thing. And then I'll go ahead and push my updated top scope back onto, and I actually did the wrong thing. I said it right out loud. I'm going to push my extended scope back onto my temp environment. That is the scope I've now fixed. Original top scope, extended top scope with my new name value pair, the rest of my environment except for the top scope. And then I'll go ahead and recreate that environment by pushing my extended scope back onto it. That makes sense? All right. So then down here, when we define our environment, we went ahead and we said our environment is going to be A, C, D, E, blah, 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 all that stuff. I'm going to go ahead and comment out these couple of things. And I'm just going to print out my environment. Oh, I didn't write extend env star. That's fine. A6 extend env b7 onto the empty env. All right, so here's my list. This is my stack of environments. So this is a list containing a single scope, and that scope is going to be an extend scope B7 onto the, actually this is, Oh, I'm calling extend env multiple times. This is going to be extend, well, no, it's correct. Extend environment A6, extend environment B7 on the empty environment. Getting the right values in here, but they're in the wrong order. So this should say extend scope B7, extend scope A6 onto the empty scope. So my extend env that we just wrote is slightly off. Extend env takes in a var name, var value, and an environment. It grabs the top scope off that environment. It extends that scope with the var value onto the top scope. Okay. And then we push that change scope back onto the remove scope. Temp environment. Let's make sure remove scope does what we think it does. Yeah, it just returns the footer, everything but the front of it. So this should give me everything but the top scope inside of temp env. We're pushing my updated scope onto that guy. So I call extend env once, I get this. I call it a second time.
In the push scope, the two parameters you're taking in, take the environment through first and then the scope.
Push scope. Uh-oh, thank you. So then for extend env, we need to give it the, oh, I called it right. I just wrote it backwards. Thank you. All right, that looks correct now. All right, so for your homework, and I'll push this, update our apply expression to now use this new environment. We're only going to have to do it in a couple of places, right? Only a couple of places do we actually use the environment. We use it with remembers. We use it with get value. Okay, so make it compatible with our new type of environment. So I'll go ahead and push this. So updated for stack of scopes based env. And then push origin. All right, questions about what I'm asking you to do? Shouldn't be very difficult. Basically, you want to go and create some, you want to go through and look through and see where do I currently use my environment in my apply expression, and then update it to make sure that it's using our newly formed environment. You might not need to make very many changes since this guy already has the same abstractions, but at the very least, go through and make sure it's compatible with everything. All right, questions, comments, concerns, bribes. All right, I'll see everybody on Tuesday.